Hi, anatomy students. Look at you, on to lab 2. Okay, so if you are here, if you're watching this video, you have gone through lecture 1, you've gone through lab 1, hopefully you've tried the questions for lab 1, and you've watched lecture 2, which is on, it's a little bit of chemistry. That will help you a bit in this lab. So this lab has a couple different parts. There's 3 different parts, sorry. It has, so if we open up the lab, come on, come on. Okay. We're gonna do that. That's fine. If you click on the link, it might just open as a PDF. Download below, so click there. Let's just take forever. It's cool, computer. You got this. It's fine. Here we go. All right. So when you open up the lab, here's what you see. First of all, you might notice that it's not as long as lab 1 was. I think it's only 4 or 5 pages, but that's because all 3 parts of this lab happen in simulations. Now you'll notice here's a bunch of bold words. That means they're fair game for the lab practical. So these are good things to define. You might define them at first. You might define them as you go through the lab. Either way, they're words you're going to need for these labs, okay? So these 3 labs work with some basic chemistry. One is diffusion. So in the first lab, you're going to be dealing with diffusion. You're going to look at how particles move and what affects how they move through membranes. So membranes are kind of like a doorway, okay? So if you have a semi-permeable membrane, if you have a non-permeable membrane, nothing can get through. If you have a semi-permeable membrane, only certain things can get through. So it's kind of like a doorway with a bouncer. The bouncer will let some things through, not all things, okay? And so in this case, what's causing that, allowing the movement of particles is this random motion of particles. It's called Brownian motion. Particles are just rolling around, jumping, bouncing off each other, and over time, they end up spreading out as much as possible. And if you have a semi-permeable membrane, that means there's going to be as much on the inside of that membrane as there is on the outside of that membrane. Well, what's going to cause that to go quicker or slower? Your smaller particles are going to move faster. If you have more energy, your particles will move faster. If you have more stuff, they're going to move faster because there's more stuff for it to bounce off of and spread out, okay? So this will let you go through that. As you're going through these labs, so what you'll see is when you are... Yeah, okay. When you are, so you're looking at this, and it says it gives you a little bit of an introduction. And then you're going to go, and you're going to go to part 1, diffusion across a membrane. And then you're going to click on this guy, and it's going to, this one, there you go. And it's going to take you into the McGraw-Hill, and it's going to look something like this. I can't get the whole screen here. It's fine. Okay. If you're worried, what should I take notes on? The key concepts are the things you should take notes on. As well as over here, sometimes you can scroll down more and you get more definitions, okay? So this just kind of gives you an idea of what you're working with specifically in this lab. However, the key concepts are going to be the ones that are going to be the more important ones across anatomy in general, okay, and physiology. Because technically this is a lab, so it should be anatomy, but it's physiology. They're very closely related. Oh, this is how enzymes work. We want to look at, there we go. This is lab 1. Okay, so again, here is the stuff, the key concepts. We're talking about diffusion, the movement of particles, okay? And over here on this side, before you begin, you want to make sure you know what you're working with. So you're working with starch. Let's see, what is media? Okay, it's what you're going to let stuff diffuse through. What's a solution? What's a solute? What's a solvent? Okay, here's where you can write down those definitions on your lab. My dog is very excited about it as well. Or a squirrel. Okay, so that's lab 1. As you go through this, so in all of these kinds of labs, it's going to ask you to make a hypothesis. And what's your strategy? Now, here's the best thing about science. You can't be wrong on your hypothesis. I mean, you can, obviously. You could guess something. And remember, a hypothesis is an educated guess. It's where you're like, well, I know that diffusion happens, so maybe everything can diffuse. I don't know. So, and a lot of times in early science classes, they tell us that, oh, there's only one kind of scientific method. You do your hypothesis, you make a hypothesis, you test it, you're done. That's not actually how science works. Science says, hey, I have a question. I just want to see how this works. I know a little bit about it. I'm going to do a little bit of a test, see how it goes. Do another test, see how it goes. It's kind of like when you want to ask someone out. You usually don't want to just run up to them and be like, oh my God, marry me. If you've never met them before, maybe you talk to them a little bit. See how it goes. Maybe they like it, so you keep talking to them. You talk to them a little bit more. And then, oh, they don't like it? Oh, my hypothesis was incorrect. We're not getting married. Cool. Go back, make a new hypothesis, meet someone else. Same thing in science, okay? You might have an idea, like you can literally pick any one of these you think is going to be the most correct that you're going to be testing, and then maybe talk about, I'm going to see which one of these two things I'm going to do. I'm just going to pick two random things, see what happens. Oh, my strategy, maybe I need to go back and read and figure out what the heck iodine's gonna do. Interesting. Or maybe I'll just click that and see what happens. The nice thing about doing these virtual labs is that you can't actually spill the iodine on yourself or run out of material because, hello, you're doing it on a computer. Okay, so then you're gonna go into the lab and you're gonna start again like you did in the first two first two parts of the first lab. Just follow the instructions, okay? Take a piece of dialog, just it walks you through it. It's gonna let you take data, okay? So before diffusion, this happened, and it'll tell you when to do it, okay? So then you'll follow this through. You'll go through your 4 stages. You'll finish this up, and then, yeah, you're done with the first part. And then you're going to go into the second part. Okay, my dog's just going to bark forever. It's fine. So you go and you read this, and you're like, oh, cool, I finished this first part. That's great. What's next? Next is osmosis in red blood cells. What? So you're going to go back to home. You're going to click on osmosis in red blood cells, and you're going to see this. Oh, my dog just wants to make sure all the squirrels know that he is the king of Squirrel Town, I guess. I don't know. Okay, so osmosis. What is osmosis? Osmosis is a kind of diffusion, but it's technically looking at it from the water standpoint. So if you have 2 areas and you have a really salty area, let's say you have I'm a marine biologist by training, and so I always think about fish. If you have a freshwater fish, it's basically a bag with a bunch of salts in it that swims around, and it's in water that's pretty fresh. So your fish is very salty in a very fresh body of water. What's going to happen to the water? So there's less water inside the fish compared to the water around it. It's much more concentrated inside the fish, so there's less water. So water wants to get into that fish and say, hey, it's cool, it's a party, let's all even out. The problem is then the fish would explode. So the fish has to be able to take care of that kind of thing. Same thing can happen in our cells. If you have a red blood cell that is in a very dilute, let's say you drink so much water, oh my God, and you literally don't eat for days, you just drink water and you drink water and you drink water. Well, your blood is going to get really thin. That means it's going to have a whole lot of water in it, not a lot of other stuff in it, which means every blood cell is going to seem really, really concentrated, and the water is going to go rushing in there and make the blood cell explode. Oh no, am I giving away too much of the lab? I should stop talking. Okay, so again, I would write down your key concepts and your definitions here, okay? And then again, go through the lab simulation. Okay, you're going to make a hypothesis, you're going to talk about your strategy, and then you're just going to follow the different stages. Okay, cool. Are we done? Almost. You have one more part, and that is to talk about pH. Now, in the lecture, I talk about pH a little bit. I get a little manic talking about it. You guys, quarantine is hard. But what happens is this the right one? Yeah. So pH is how many hydrogen atoms are present. And remember, the more hydrogen atoms that are present, the more likely bonds are to be disrupted. Okay, so the idea is hydrogen is everywhere. It's the glitter of the chemical world. It's going to bond to everything it possibly can. But if there's too much hydrogen around, it's going to start sneaking its way where it shouldn't be, okay? And so it's going to get in there, and it's just going to start blowing up those bonds, okay? That's really bad if you have a very big molecule and you want to keep it together, like an enzyme. So enzymes are, I like to call them proteins with a purpose. So they have one job. But if you mess them up with the different pH, what happens? That's what this lab is going to look into, okay? So you have your 3 parts of the lab, and then you have the lab questions that go with it. And then you're done with day 2 of anatomy. It might seem like I'm kind of throwing a whole bunch of stuff out there in the first day. What I like to do in these online classes is kind of front load the week. So then you have on today and tomorrow, I'll be putting a lot of stuff online. But then Wednesday, Thursday, Friday, I'll be available for questions more than I will be just chunking a bunch of stuff online to kind of overwhelm you. Okay, so don't give up. You got this. I believe in you. Several people have already reached out with different kinds of questions and concerns. Wonderful job. And also now I know them, and I'm more likely to be like, oh, you're like a 79.5, I'm going to bump you to an 80, that kind of thing. Always reach out to your professors, okay? Just life lesson. We're very sad, lonely people. No, we're not, but we like to pretend we are. Okay, so that's all for me on Lab 2, and good luck. Let me know if you have any questions.